Hello everybody, this is Daniel Morrison, software engineer from Matrix TSL, and today we're going to be looking at the C simulation feature in Flowcode 8. If we begin by starting a new project and we select an appropriate target for our hardware, remember that if you're not compiling to a microcontroller you can select a node chip, but for the purpose of this video we'll select just for example the 16F1508. So once we open our project and close some windows from our last session, which we won't be needing in this, we'll see the familiar dashboard panel or the 3D system panel, which we'll be using for this project, the properties pane and the icon lists, which we also won't need for this project. So let's start by creating a C code icon, which we have always had in Flowcode, so Flowcode 7, Flowcode 6. These allow you to type in custom C code commands. Now, the problem with Flowcode in the past has been that when you simulate your flowchart, so this is not compiling to the chip but running the simulation engine within Flowcode, these C code icons are generally skipped over. So you could have any number of flowchart icons, delays, input-output icons, for example, and these icons will be simulated, but whenever the simulation encountered a C code icon, for example this one here, it would skip over it as if it weren't present. Now, if you've purchased our new C simulation feature pack, at which you can check by going to Help and View Licenses, so you'll see me just hovering over it there, then this is not the case any longer. So you'll be able to simulate any C code blocks you've written, and to enable this you select this icon here on the toolbar where it says C simulation. If you select this prior to beginning simulation, then Flowcode will actually convert the C code you've written into simulatable code. So let's actually work through a short example so we can show this off. So we're going to select the eBlocks panel and we're going to add the combo board, the eBlocks 2 combo board, to the system panel. So we just drag that on and you'll see we have a 3D model of the combo board. Now you'll notice as well that where I'm hovering my cursor, you have the LEDs A0 to A7. So actually in hardware, which is what we'll also be simulating in software now, these LEDs are connected to port A of the combo board. So if we were to output a number to port A, this would actually this would change the values of the LEDs. So they'd be on if the corresponding bit, for example A.0, were set to 1, then this LED here, which I'm hovering over, would light up. Now you can simulate this in Flowcode 7 and previously by using output icons. For example, let's say we set the value 255 to port A. This would change the value of this LED array, and we'd be able to see it lighting up on screen. But if we were to write equivalent code in the C code icon, it would not be simulated, but now we can. So let's work through a short example of C code. Let's create a variable, an integer variable called LED value, and we'll set it to 0. And if you're familiar with C code, this should look well familiar to you. So this is relatively simple C code. It's very beginner level. It's the sort of C code you'd be learning if you were very new to programming. We're going to create a loop, a while loop, which is a common construct in C. We're going to say while LED value is less than 255, if you forgive my bad typing, increment LED value using the unary ++ post increment operator. I think that's correct, yeah. So what we do here is we increment the value of LED value by 1 every single time we go through this loop up until we reach the value of 255. Computers are naturally quite fast, so if we were to simulate this or program it to a microcontroller, this number would go up to 255 so quickly that we wouldn't actually have opportunity to witness the program as it executes. So we're going to use a delay function as well. So we have FCI delay byte _s, and we'll pass the value of 1. So this is one of Flowcode's functions which get generated historically by the icons. This is the C code which gets produced by your flowchart, but now we can actually invoke these functions directly in simulation. So the delay byte signifies that we can pass any value up to 255, and the _s means that we're working in seconds. We can actually change this to ms if we wanted, for example, milliseconds, and but that's not something we'll be doing. 1 second is a quite big delay. So what we need to do as well is, so this increments the value of LED value by 1 every second. We want to now output this to port A. So we have these nice new ports setting and getting functions. So set port A, and we can pass the value of LED value. So you'll see now if we press OK, we have a C code icon which creates a variable, sets it to 0, and increments it every second up to 255. And each time it changes the variable, it outputs the value to port A. So if we just check that C simulation is checked here on the toolbar, and we press play, we'll see some conversion messages. We'll see our familiar watch window. And over here in the system panel, we'll see that the value of port A is actually being incremented, and it's being output. The value of LED value is being incremented. It's being output to port A, and the LEDs on port A are changing value in the simulation to reflect this. What we can do as well is, if we slow the simulation speed down, we can use the watch window from Flowcode 7, and we can actually view the value of these variables which we've defined in C code. So here we use dot to signify it's a local variable, and we type in the name LED value, and we'll see here that the value is set to 40 as I'm speaking, and it's going up at a rate of roughly 1 per second. So that gives a very basic overview of the C simulation functionality in Flowcode. What's quite useful is this conversion messages window. So let's say, for example, you're typing out some C code, you declare a variable like LED value, but when you go to use that variable later on, you use a typo. So here I've removed the U from LED value where we increment it. So the result is now LED veil. If we attempt to simulate this now, we'll see that we get an error message in the conversion messages window. So statement LED veil ++ failed to convert does not correspond to a valid Flowcode assignment. And we'll see that the explanation it gives is because LED veil is not valid. And this can be quite useful. So if you're embedding custom C code in your project, of course you can go to compile it to the target and you'll get a compiler error. But now in a somewhat faster turnaround, you can attempt to simulate the C code, you can view any errors that happen, and you can of course view the effects of your C code as well. So you're no longer having to compile your C code all the way to the microcontroller, which turns it into a kind of black box where you can't really see what's going on. You can see the effects of your C code in Flowcode. This C simulation engine as well, it supports all the basic constructs of C, with the exception of pointers, which hopefully you won't be needing to use very often. It's not very common to use pointers in microcontrollers. But all the standard constructs, so variable declaration, assignment, control structures like loops, we can write if conditional statements, for example. We can invoke some of Flowcode's useful functions like the delay function, the set port. We can do set port pin, for example, get port. We can interact with the various pins of the microcontroller using this C code simulation engine, and we can get a very good idea of how the program's going to perform when it reaches the target, now even when C code is embedded in project. So hopefully that gives you a good idea of the new C simulation feature in Flowcode. If you like this video, I'd like to recommend that you check out some of the other videos in the series. Thank you for listening.